Hey students, welcome to another physical geography class with Mrs. T. We're going to talk about the difference between weather and climate in this lesson because we're jumping to chapter 8. In the 12th edition anyways, it's chapter 8. It's on climate and climate change. And one of the fundamental things we have to start with is the difference between what weather means and climate means, because those words are not interchangeable, and so often I hear people use them kind of interchangeably. They're very related to each other, but weather is on one end of the spectrum and climate is on the other end of the spectrum. And the spectrum I'm talking about here is a time span spectrum. So weather is what's happening now. You can open your door and look to see, is it sunny? Is it cloudy? Is it windy? Is it gonna rain? Are there tornadoes forecast? Is there, massive instability? Is it gonna freeze tonight? Is it gonna be 115-degree heat index tomorrow? These are the kinds of things that are part of the weather and your understanding of what's happening right now. And it can change moment to moment, as the graphic says. Just wait a couple hours. You don't like the weather now? Wait a couple hours. It can be very different in just an hour or two. At least that's the joke that a lot of people have about weather in Arkansas. I'm sure people who live in other places have that same joke too. Climate, on the other hand, is a long-term measurement of these things. And when I say long-term, I'm not even just talking about the 12-month cycle that we know and that we've focused on, the seasons of the year, for instance, that we've learned about so far. Yes, obviously there are expectations for what fall weather is going to be like at a certain latitude, and there's expectations for what winter weather is going to be like at another latitude. And so those seasons of the year, you should expect these changes. But even that is not long-term enough for what we should expect with climate. Climate is a prediction. It's an expectation. It's a result of years and years and years of collecting information about weather patterns and data about the amount of rainfall, the kinds of plants even that can live in a certain place, the range of temperatures over 50 years, half a century or more, as long as we've recorded data. And there's been centuries of data in some places and not very much data in other places. And so we measure the patterns of weather that are expected over a long period of time, a decade, which is a group of 10 years or more, over a long period of time. And that's where we get the concept of climate. And so I have another graphic that I'm going to switch to now. This is a graphic that I use a lot because I love to garden, and I just talked about what kind of plants maybe are going to be alive in one zone or the next. And so this is a climate zone map, and this climate zone map has been developed over years and years and years of looking at data about rainfall and temperature variations. How cold does it get in the winter? How warm does it get in the summer? For how long? How much angle of incidence of sunlight does this area have in this latitude? So there's a whole bunch of different data points that have gone into the development of a chart like this. And so, for instance, Arkansas is down here in the kind of yellow-orange zone 7, where the average Fahrenheit, cold temperature Fahrenheit that we get can be on average 0 to 10 degrees in zone 7. And so in Celsius, you can see that is converted in this chart. We have the Celsius conversion also. -18 to -12 degrees is the Celsius equivalent. But in zone 7, it gets down to that temperature. And so a lot of times, if you're planting shrubs that you want to grow year to year in your yard, you have to make sure that you get a shrub that is hardy, I'm doing my air quotes, hardy to zone 7, which means that it could have some 0-degree temperatures over the winter. And so you have to be careful about that kind of thing. So maps like this that show you this climate zone or growing zones, these kinds of things are developed over years and years and years of collecting weather data, temperature variations, and you can see these patterns that exist in society. And this is just one way that we can represent those patterns graphically. Another way that we represent them, that you'll see in chapter 8, you'll see in your climate section of your textbook, are these climographs. Now, these are bar graphs and data that you can collect information, and let me show you how to read these. Now, I've got 3 examples on the board here. One for a desert climate, which typically is considered hot and dry, although the hot part is not always necessarily so. And then a tropical rainforest, which is typically considered warm and wet. And then a taiga, which is typically considered to be like a permafrost or an icy area where you can see here, we'll look at it in just a second, the temperature does not really get very often and very much above 0 degrees Celsius. So we're at the freezing point most of the time. And so you can see, you have climographs all through this chapter of your textbook for you to read and interpret. You will always have precipitation in millimeters over here on this this side. 250 millimeters roughly is about an inch of rain. So I know that we are in the standard measurement that we use here, but these climographs are usually in metric. And also we use Fahrenheit most commonly. We know about Fahrenheit, but these climographs are going to have Celsius on the temperature scale. So you have over here precipitation on this axis, you have temperature on this axis, you have the months of the year down here on the x-axis, January through December, and then this dot line shows you the average temperature that you can expect during what time of year, and how much precipitation is represented in these little blue bars on this graph. And so you see a desert has very, very little precipitation, and it's usually this May, June, July season when it is the driest in this particular example. Whereas look at all this blue on this tropical rainforest climograph. This is a significant rainfall place, right? And you can tell which months of the year, like March right here, has the most rainfall in this particular example, where you get like an inch and a half of rain or so is the average for March, and the temperatures stay just above like maybe 26 degrees Celsius. And so let me just do the conversion pretty quickly. In my mind, we're in the 90s, right? We're in the 90s. It's going to be very humid, lots of rain, a high temperature, and the precip, values are going to be up around an inch or an inch and a half per month. That's a lot of rain that we're going to get. Okay, and then I said over here with the desert climate that you see that's not very much rainfall. Actually, over here in the permafrost, it's also not very much rainfall. You see that 0 degrees is pretty much the standard here, and the precip is well down below half a centimeter down here. And so you don't get, mostly you have a couple of months that are above that centimeter mark or half a centimeter mark. But anyway, in this area, you have very dry climate usually, and a lot of sublimation happens, a lot of deposition, water vapor becoming ice, and sublimation, ice becoming water vapor. And you skip that liquid cycle most often in this particular type of climate. And so this is how you read these things, and this is where that data comes from. We're not simply talking about one period of time from January to December. You're talking about looking at a lot of Januaries to December to come up with the climate patterns that you should expect for a certain place at a certain time. And that's where you get these kinds of maps, so that you know what averages are over 100-year lifespan, what 100-year high and 100-year lows are. That's where the records come from, because we look at that long span. And so the difference between weather and climate is what's happening now and what the long time trend is. And so please